Hi everyone, thank you so much for coming to this video. So today we're going to be going over hypothesis testing for normal distribution. So please review the videos on hypothesis tests and also on the normal distribution, as we're going to be using that in this video. So the learning objective is to be able to conduct a hypothesis test for the mean of a normal distribution. I'm going to be taking you through two worked examples to show you how to do this. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So we can use hypothesis tests using a normal distribution to test a population mean for a normal distribution. And this is through using a sample mean of our normal distribution. So the steps to carrying out this hypothesis test for a population mean, which is called mu, is first you just write down your population parameter, which is your population mean mu, and then you want to write down your null and alternative hypotheses. Then you want to state your significance level. You then want to find the value of your test statistic. So if your x standard variable x is normally distributed with mean and variance mu and sigma squared, then you could say that your sample mean x, so it's just x bar, is normally distributed with parameters mu and sigma squared over n. So this x with your bar across that's your sample mean. So then once you've done that, you can then test your significance either by finding your p-value or finding the critical region like we did with the binomial distribution hypothesis test, and then we just want to write down our conclusion. So let's try these steps out with this example here. So we have the weight of beans in a tin produced by company A. It's normally distributed with a mean of 415 grams and a standard deviation of 3.4 grams. Company A suspects that the mean weight of tins from a machine is lower than it should be. Write down the company's null and alternative hypothesis. So you could call that part B. So I've just skipped out part A because it wasn't relevant for what we're doing here. So the first thing we want to do is we just want to write down our null and alternative hypothesis. So our H0, would be mu, is just equal to our population mean, which we have is 415, and our H1, our alternative. So we're testing, the company suspects that it's lower than it should be. That means our mu would be less than 415. So part C, a sample of 20 tins is taken and the mean weight is found to be 413 grams. So we want to carry out a test at the 1% significance level to see if there's evidence that the machine is producing tins with a mean of less than 415 grams. So we've done the first and second part we know that our population parameters are population mean. We've written down our null and our alternative hypotheses. So now we want to state our significance level. So alpha would just be 1%. So now we want to test our significance by either finding now we want to find the value of our test statistics. So we can say x, which is our weight of beans. So we can say that x, that will be normally distributed with our mean, which is 415, and our standard deviation, which is just 3.5. So our sigma squared would be 3.4 squared. So now we want to use our sample mean, which is x bar, and we want that to be normally distributed with our mean, which is still 415, and our this bit here, sigma squared over n, so that would just be 3.4 squared over our n. So because our sample is 20, so it'll be over 20. So that's our new parameters for our sample mean. So now if we want to test our significance, either by finding p-value or finding the critical region. So we can firstly do this using, we first find our p-value. So we want to find the probability that our sample mean is less than or equal to the value that we've got here, which is 413. So we're doing less than or equal to because we're just our hypothesis test is a one-tail test, but on the lower end. So and now because we're testing the mean from our sample, so we want to use the sample mean and the normal distribution for that. So we can just use our calculator for this, going onto our normal CD function on it. So our lower end that you would put in would just be minus 1,000 because it's all values below 413 and it would go all the way to a really low value. Your upper value would just be 413. Your sigma that you put, that would just be your square root of 3.4 squared divided by 20, so the square root of this value here, and your mu is just 415. So that, if you apply that in your calculator, that will be equal to 0.00426 to 3 SF. So now you just want to compare this to your significance level. Significance level is 1%, which is also 0.01. So 0.00426, that's less than 0.01. So therefore you can reject your H0. So remember, if your p-value is less than your significance level, you reject it. If it's more, you don't reject it. So that's how you can carry out your hypothesis test using the p-value. So now let's try and construct a critical region. So you do the same process as we did with our binomial hypothesis test. So you just want to find the value of your sample mean when the probability if it's less than a value x, and you want that to be less than or equal to 0.01. So you can also see this if we draw out our normal distribution for the sample mean. We'd have 415 is our mean. So we want to find a value of x here that this value over here would be 0.01. So we want to find that value of x. So in order to do this, we want to standardize this to make it into our standard normal distribution. So we want our p to be z is less than or equal to. So we just standardize our x value. So we do x minus 41, our mean, which is 415, all over the square root of this, so it'll just be all over 3.4 over the square root of 20, and we want that to be less than or equal to 0.01. So then we can say x minus 415 over 3.4 over the square root of 20. We want that to be less than or equal to, if we do the inverse of 0.01, and if you do the inverse of that on your calculator, if you type 0.01 in, you should get that is equal to minus 2.33. So then we can just rearrange this. So we could do minus 2.33 times 3.4 over the square root of 20. So we would get x minus 415. We want that to be less than or equal to minus 1.769. So then if we add 415 to both sides, we want our x value to be less than or equal to 413.23. So we have this value here, that'll be around 413.23, that's fine. So now we want to see what the value that they gave us is, and the value that they gave us was 413. So you could say that 413, that's less than 413.23. So therefore 413 is in our critical region, as our critical region was values of x mean, which is less than 413.23. So therefore you reject H0. So therefore you just write there's insufficient evidence. So therefore, your last step is you want to write your conclusion. So you say, therefore, there's sufficient evidence to suggest the mean weight is less. So when we did either through finding our p-value for the normal distribution and also by when we found our critical region, we got the same conclusion that we're rejecting our H0. So you just want to follow all the steps when you're when you're testing your population mean. So the first main step is you write out what your tested statistic is and its distribution, and then you want to work with your sample mean distribution, so that would also be normally distributed just like your other random variable, with the mean would be the same. The only difference is that your sigma squared now would just be sigma squared over your sample size, so sigma squared over n, so you need to be really careful with that. And then if you're working with p-values, if it's a lower end one-sided test, you do your sample mean less than or equal to the value they give you. If it was an upper tail to a one-sided test, it will be your sample mean more than or equal to that value, and you could just plug that in using your calculator. If it was a two-sided test, then you want to work out what your mean is. If it's on the upper end of your mean, then you would go more than or equal to that value. If it's the lower end, you'd go less than or equal to that value. And then you just want to compare it to your significance level. For a one-sided test, it's just the significance level they give you. But remember, like with all hypothesis tests, if it's your two-tailed test, it's just your significance level divided by 2. And if your p-value that you get is less than your significance level, you reject your null hypothesis. If it's more, then you don't reject your null hypothesis. So that's the p-value method. The critical value method. So for one-sided test on the lower end, you just want to work out the values of x, that if you were to do the probability that your sample mean was less than that value, you get less than or equal to your significance level. So you just want to standardize this and then do the inverse and rearrange to get what your value of x would be. And then your critical value is just your sample mean less than or equal to that value. And then you just want to see if the value that they give you is inside your critical region or not. If it is, then you reject your null hypothesis. If it's not, then you don't reject your null hypothesis. If it was a one-sided test but on your upper end, then you would have done x is greater than or equal to x, less than or equal to your significance level, and you would do 1 minus, and then you would standardize just like you do normally. If it was a two-sided test like we did with binomial, you want to do on both ends, and you just want to divide your significance level by 2 and then just do your standardizing, but for both ends of your normal distribution. So that's everything you really need to know about hypothesis tests, but for the mean of a normal distribution, and we've got the steps here. So let's try another exam style question to see if you fully understood this. So we have another exam style question here. Feel free to pause the video and try it out for yourself first. So we have the length of the bus journey from Leeds to London is normally distributed with mean of 220 minutes and a standard deviation of 8 minutes. So part A, we want to find the probability of the bus taking longer than 235 minutes. So this is just normal distribution. So you just first write out say your x is normally distributed with mean 220 and standard deviation 8. So this parameter would be 8 squared. So then you just want to find the probability that x is more than 235. So then you just go on to your normal CD on your calculator. Your lower would be 235, your upper would be 1000, your standard deviation, that's just 8, your mean is just 220. That would be equal to 0.0304. to 3SF. So that's the answer to part A. Part B now, the bus companies suspect that the mean bus time has changed. So you want to write down a null and alternative hypothesis for a two-tailed test. So H0, that would just be our mu is equal to 220, so what they gave us over here. And at H1, they've told us it's a two-tailed test, so it's just mu is not equal to 220. Okay, part C, they take a sample of 10 bus journeys and find a mean time of 230 minutes. Test at the 1% significance level whether there is evidence that the mean time has changed. So first thing, we know what our x is normally distributed, so we just want to do our sample mean. So that will be normally distributed with parameters 220 and 8 squared over our n, which is 10. And we can also write that our significance level is just 0.01. So now that we have this, we can either use our p-value method or our critical region method. So feel free to try both. Because they haven't specified, you can just do whatever's easier for you. I personally find the p-value method easier, so let's use that. So we could just find the probability that our mean, so they found a mean time of 230. So because that is more than our mean here, we're going to do the upper end of this. So it'll be the mean, sample mean is greater or equal to 230. So we can just plug that into our calculator on the normal CD. So our lower end will be 230 now, upper end will be 1000. Our sigma would just be 8 divided by the square root of 10. And our mu is just 220. So if you work that out, that would be equal to 0.000386 to 3SF. So because it's two-tailed test, you want to compare it to your significance level over 2, which is just 0.005. So then we want to compare this for our p-value to 0.005. 0.000386 is less than 0.005. So you therefore reject H0. So you therefore say sufficient evidence to suggest mean time has changed. So that's the answer to this question. So yeah, just recognizing it's a two-tailed test and remembering to do your sample mean with this parameter here being your sigma squared over n. And then because if it's a two-tailed test, you need to remember to compare your p-value to your significance level that they've given you over 2. That's everything. Thank you so much, everyone. Hope you found that useful and you now understand how to conduct a hypothesis test for the mean of a normal distribution using the steps that I've listed over here. So make sure you do some practice questions just to make sure you fully understand everything that we've covered.